Okay, so this is going to be, I think, the second part of sample problem 2.1, where we're going to do the problem again. All right, so here was the problem. All right, as you could see, that we're going to add. We want to find the resultant of P plus Q. So we had R, but we're going to use this same triangle right here. I might be able to fit everything onto here. So maybe I will try to squeeze it on here. I don't like doing that. But what I'm going to do is I'm going to use the law of cosines and sines to solve this. All right, so I have this written down somewhere. Okay, so it's easier to sometimes just to do a little cheating. All right, so I know that this is equal to 40 degrees, and I know that this is equal to 60 degrees. And I know the angle. I wish I had left this thing taped down on one level, but let's see. Right here. But you don't have to do this. In fact, you don't have to do it by way of using your drafting supplies. In fact, it's probably better not to, because like on an exam or whatever, you want to do it by an approximate method here. So let me draw this separately. All right, so here is me redrawing with the best I can. I don't have to be perfect as part of this. So like I'm using this as a reference, and I will draw what I think is about a 45 and say here is Q, and then I'll do this one. I can kind of approximate that, and this is P, and I'm drawing this thing out, right? And I say that Q is equal to 60 newtons at 45 degrees, and P is equal to 40 newtons at 20 degrees, and I want to find R, which is going to be equal to Q plus P. But I want to do it with law of, I want to do it by way of trigonometry, right? So I take this out, and I don't have to be perfect with my lengths. I just want to try to be as pretty good, right? So here is Q, and here is P. And then I know that this right here is going to be R. So what I need to do now is to start thinking about the angles that are involved, right? All right, so I know the magnitudes aren't too hard. A lot of times we were given some angles, but now we want to find interior angles. This is like the hard part sometimes. So we have to use like a bit of logic as part of this to try to figure this out. And I'll use this as a straight edge to show. So I know, let's say right here, right? And I should have probably put this as part of my thing. Like here was 20 degrees, and right here was 25 degrees, right? So I know this angle right here is 25 degrees. It's hard to see that, right? But I also know this guy right here is 45 degrees, right? So if I were to draw a line like right here, I would know that this too was 45 degrees, right? See, is that to right? Does that make sense? That's 25 degrees. Here's 45 degrees. Therefore, what remains right in here is 135 degrees, right? 135 degrees. So the total angle that's inside there, which I'm going to designate as beta, not going to fit, so it would be like really confusing. So maybe I want to redraw this triangle over here to name what I'm going to name stuff. And I'm going to call this one beta. I'm going to call this one psi, and I can't remember what that guy's called. I think he's phi. All right, so So I like to use beta, psi, and phi. I think those are the correct ones, right? When dealing with angles, because like alpha gets used for lots of stuff and theta gets used for a lot of things, so I try to avoid them and use these angles. And so this is just going to be R right here, and this is P, and this is Q, right? So I'm just designating these so I can use the law of sines and law of cosines. So what we know here is that beta is equal to 155 degrees, right? 100, no, is that true? Wait a minute, I just messed something up here, didn't I? Oh, this was 20 degrees. That's why. I'm sure you watching the videos, no, that was 20 degrees. Yeah, okay. 155 degrees right here is the total of 135 and 20, because we broke the thing apart. And we also happen to know that P is equal to 40 and Q is equal to 60. And I guess we'll say what the units are, right? Those are just the magnitudes. So what we want to do is we want to find the magnitude of R. And so now we want to go, so these are adjacent sides to this angle right here. So we use law of cosines. So law of cosines, right? Write down what I'm doing. And then say, and I should be doing this on maybe engineering paper too, but I don't have any at home right now. I guess I could have printed out the simulated engineering paper. That would have been better. And I got to get better lighting. Anyway, this will all be better soon. So law of cosine, which is going to read for us is R squared is going to be Q squared plus P squared minus 2QP cosine of beta, right? So R is going to be equal to the square root of, stick Q in there, 60 squared plus 40 squared minus 2 times 60 times 40 times the cosine of 155 degrees. And you don't need to necessarily see me do this on my calculator, but I might demonstrate it anyway, because I like to try to encourage people to consider getting the Hewlett-Packard calculators. It is the engineer calculator. I mean, if you're an engineer, a lot of times that'll be the calculator for you. I'm not sure you're going to be able to see the screen, but the method that you use for the HP calculator is called reverse Polish notation, RPN. And there's no equal sign. What I do here is I go 60, and now I square it, and that's a secondary function to my square. And then I have 40, and then I enter 40, and then square it, and then I hit the plus, and that adds those two together. This stays in something called the stack, and that just rolls over onto the thing. So I just leave that alone. I go back over and to the next function. I go 2, all right, and then I have 60, and then I multiply. I have 2 and 60 in my bank right here. I hit the multiplication. I multiplied those, and then I hit 40. And then hit multiply, boom, and that has just multiplied there. Then I hit my 155 and take the cosine of that, and then also multiply. So now in my stack, I have what was this guy, and you notice that, by the way, it became negative. And then I just subtract right here, and now I have with everything inside, and then I hit the square root, and I end up with 97.73 newtons. Right? So I was able to get the magnitude, and if we check in our textbook, that's the exact same thing that they got. Now I want to get its angle, and that angle is really going to be this angle right here. So I need to get this interior angle and subtract it from 45. So that's the phi that I'm going to call. So I'll use law of sines to be able to do that, right? So the law of sines, LOS, right here. And maybe we want to get a little closer. Maybe that'd be better. A little closer. Right here. All right, so the law of sines is going to be, let's see, the most useful one for me to find that phi is, I know P is a phi, right? So I'm going to go P over the sine. Did I count phi? I think it's psi, yeah. Is going to be equal to, now I know beta and I know R, so I just found R. So it's going to be the sine of beta right here, right? So plug in numbers into there. That's going to be 40 divided by the sine of here. This is what we were trying to get. Is going to be equal to 97.73 divided by the sine of 155. And I don't have to draw the in-between steps for here. So I say, okay, the easiest way for me when looking at this, I'm going to say that it's going to be 40 divided by 97.73. Right? It's actually still in my stack, by the way. I can just go down to there. You can see that that number is still in there. So I can use my swap button. Where's my swap right here? So now I have 40. So I want 40 divided by that. And I want to multiply by the sine of 155. Boom. And then I want to take the inverse sine of this. So I take my secondary button, inverse sine, and I end up with 9.961 degrees. And so my answer, okay, so what for my angle, I actually need to take 45 minus 9.961. So up here, what I usually do is I go 45 and I go minus, and I know it's going to be negative there, but I end up with a 35.04. I could also have done the swap thing to get them around, but I decided to do this. So that's going to be the actual angle. So the answer, I always want to write the answer at the very end, is going to be equal to 97.7 newtons at 9.96. Yeah, 35.0 degrees. And then I want to box it. So I box my answer. So there you go. There was the sample problem all worked out right there. Where we, and this is how homework needs to be done, right? We do a diagram, write down what the givens are, say what we want to find, then start making diagrams. Don't skip steps. Try to define stuff. Explain what you're doing, the law of cosines. Write the equation out. Write the equation with the numbers in there. Sometimes you want to go in between numbers as well. But here we got the magnitude, and then we have the law of sines. We write out the equations and things, put in the numbers, come up with here, explain where you're getting things, and then present an answer that's complete. You could have just as easily said 97.73 newtons, and if you wanted to. I don't care if it's 4 sig figs, either or, if you wanted to write that, but you don't have to. 3 sig figs is sufficient. All right, so that was the sample problem, but done trigonometrically. Now that's a hard word to say.